Titration of the prepared PSSA. First, prepare a 0.01 molar sodium hydroxide stock solution. Then take the PSSA out of the oven. Weigh the dried PSSA to know the amount of resin produced after sulfonation. The concentration of acid in PSSA will be determined by titration with sodium hydroxide. Measure out 0.02 grams of dried PSSA into a 50 ml conical flask. Then measure 10 ml of deionized water using a measuring cylinder. Pour the deionized water into the conical flask. Then add 2 drops of phenolphthalein indicator into the flask. Place the flask onto a hot plate and stir with a magnetic stirrer bar. Clamp a burette on top of the flask. Using a glass funnel, pour in the sodium hydroxide stock solution. Record the level at which the meniscus lines up on the burette. Open the tap slowly to let out 1 drop. The phenolphthalein will turn the deionized water pink after adding the base. Over a couple of minutes, it will turn back to colorless as the excess of sodium hydroxide reacts with the protons of PSSA. The titration is performed to determine the concentration of acid in PSSA in millimoles of acidic protons per gram of resin. Continue adding dropwise after the solution turns colorless. This could take around 2 hours. The end point is when the pink color remains for 10 minutes. Finally, record the level at which the meniscus lines up on the burette. Calculation of sulfonation degree of PSSA. Sulfonation is the addition of sulfonic acid groups. However, not every monomer is introduced to a sulfonic acid group. To determine the concentration of acid in PSSA in millimoles of acidic protons per gram of resin, we need the concentration of the sodium hydroxide solution, the mass of the PSSA, along with the volume of sodium hydroxide used in titration. In our experiment, we started at 6 cm cubed and ended with 10.75 cm cubed. Hence, 4.75 cm cubed of 0.01 molar sodium hydroxide was used. The equation will be the molar mass of sodium hydroxide times the volume of sodium hydroxide times 1 over the mass of PSSA. Hence 0.01 times 4.75 times 1 over 0.02 equals 2.375 millimoles of acidic protons per gram of resin. The maximum of sulfonation is when every monomer is sulfonated, which is 5.4 millimoles per gram. Hence, 2.375 over 5.4 times 100 equals 44% sulfonation in our PSSA.